Section 5.6, definite integral using substitution method. So if we have to find out the definite integral, sometime changing problem into another form might be helpful. So as you can see that on the left side it looks a little bit complicated, but after doing substitution for this function g of x as a new variable u, we can change this problem to a simple looking problem, and then after that we can use the fundamental theorem of calculus for finding the definite integral, and we can solve the problem. Before we do actual example, let's look at the two finding here. Let's say if we have to find out the integration of even function, so this is the graph of even function, the first one, and we are trying to find out the integration from negative a to positive a, where a is the same number. Then the value, the area, or the integration to the left side of 0 and to the right side of the 0, this would be equal. As you can see that they have the equal area. And if we are playing with the odd function from negative a to positive a, the integration to the right side and integration to the left side, because integration means it's a area if it's above the x-axis, and it's a negative of area if it's below the x-axis. So since they have same area but opposite sign, so while finding the integration, that will be cancelled out. This portion and this portion will be cancelled out. So we can conclude that finding here, if we have continuous symmetrical function and if the function is even function, finding the integration from negative a to positive a is equal to 2 times finding the integration from 0 to a. Similarly, if we are playing with the odd function, finding the integration from negative a to positive a is actually 0. So now let's look at some example using substitution method. The first example is we want to find out integration of this problem, and we would like to substitute, so that substitute for a function here, so that problem will be a little bit simpler looking function. So what I'm going to do is, because as it is finding the integration, because of this radical sign and because of this t outside, it's not easy. So what I'm going to do is I'm going to substitute u equal, let's say u equal 4 plus 5t, and then I'm going to find out the derivative on both sides. So I'm going to find out du, which will give me 5 times dt. So substitution means everything in term of t will go in term of u, this dt will go to du. So I want to find out the value of dt, which will be du over 5. Okay, and similarly we also have to change this limit of integration, like from a to b it goes to the value of the function at a and the value of the function of at b for that new substitution. So as you can see here, when t is 0, u would be 4 plus 5 times 0, which is 4. When t is 0, that will give us the value of new variable as a 4, and when t is 1, that will give us the value of new variable as a 4 plus 5 times 1, which is 9. So this integration after this substitution becomes 4 to 9, and then instead of t we can find out the value of t by simplifying this expression, which is, I'm going to do it here, u minus 4 equal 5t, and we would like to find out the t. So t equal u minus 4 over 5. So I can replace this t by u minus 4 over 5, and I can replace this square root of 4 plus 5t as a square root of u, and I can replace this dt by du over 5. So I can keep this constant 5 times 5 outside, which is 1 over 25, and inside we will have 4 to 9 u minus 4 times u to the power half. If you distribute this u here, it will give me u to the power 3 over 2, minus 4 times u to the power half du. So this is the integration now we need to find out. And finding this integration is easy because we just need to use power rule. Okay, so it will be 1 over 25. If we use the power rule for the first one, it will be u to the power 5 over 2 divided by 5 over 2. So it will be 5 over 2 divided by 5 over 2. And for the second one, 4 times u to the power half plus 1, which is 3 over 2 divided by 3 over 2. And then limit of integration is from 4 to 9. So if we use the fundamental theorem of calculus, now we need to put u equal 9 for the first time minus u equal 4 next time and do the calculation. We have to use this 5 over 2 as a 2 over 5, this 3 over 2 as a 2 over 3. Okay, just simplified form. Just do the simplification. If we do that, okay, if we do that, finally, I don't have the space here, so I'm going to put that value. So I'm going to flip this 2 over 5 and 3 over 5. So okay, so I'm going to just keep continue that thing. From here it will be 1 over 25, and that will be 2 over 5 u to the power 5 over 2 minus 4 times 2 over 3 u to the power 3 over 2, and then there is a 4 to 9. Now we need to put u equal 9 here first. That will give us 2 over 5 times 9 to the power 5 over 2, which is actually 3 to the power 5 minus 8 over 3 9 to the power 3 over 2 minus, if you remember the integration of the finite integral, uh, let's say from a to b is f of b minus f of a using fundamental theorem of calculus. This f is antiderivative of a small f. So negative f of a means the value of this thing at 4, which will be 2 over 5 4 to the power 3 over 2, and this negative and this negative becomes positive 8 over 3 4 to the power 3 over 2. Now we just need to simplify this expression. Before that, don't forget that this means 9 to the power 5 over 2 means it's a 3 to the power 5, because 9 means 3 squared. So I can write it down this as a 3 to the power 5. Same thing here, I can write it down is at 3 to the power 3 minus 2 over 5. This is square root of 4, which is 2 to the power 3. 2 to the power 3. This is again square root of 4, which is 2 to the power 3. Okay, now we do the simple calculation here. Just use your calculator, and then eventually you are going to get 506 divided by 375. That's the value. Let's look at another problem just by using the substitution method one more time. Here it looks complicated, so we're going to substitute for this denominator function. So let's say u equal 7 minus cosine 40, 7 minus cosine 40. So if I substitute for the top one, it will not reduce my problem, so we need to substitute for the bottom one. And now find out the du, which is the derivative of cosine 40. Derivative of 7 is 0, minus the derivative of cosine 40 is minus sine 4 times t times 4 times dt. So that is actually 4 times sine 40 dt. Okay, so I can replace this top part 4 times sine 40 dt by du. Okay, and now we have to replace this limit of integration. So when t is 0, by plugging t equals 0 here, it will give me 7 minus cosine 0, which is 1, which is 6. And when t is pi over 4, I'm going to replace this t by pi over 4, which is 7 minus cosine pi, which is 7 minus minus 1, which is eventually u equal 8. So by using this substitution thing here, this problem will now change from 6 to 8. On the top part, I can write it down just u. On the bottom part, it's just u. So integration of 1 over u is actually ln of absolute value of u, but this u is positive, so we don't have to use the absolute value. And now by using the fundamental theorem, this is ln of 8 minus ln of 6. And if I use the property of ln function, it's 8 over 6. So eventually it's a 4 over 3. So that's the exact answer. Okay, we would like to find the area of this shaded region here by finding the integration. So we know this region is below the x-axis. So if we find the integration of this thing from negative pi, which is coming from here, and it's going up to 0 of this function, which is 3 times sine x square root of 1 plus cosine x dx. If we find the integration of this, it will be the negative of the area. So the area will be actually the absolute value of this integration. Absolute value means if it's negative, make it positive. So our goal is to find the integration of this part, which we can do by using the substitution method. So we are going to substitute for this inner function 1 plus cosine x, and by doing that, we can change the problem. So let's say u equal 1 plus cosine x, then du would be the derivative of 1 is 0, the derivative of cosine x is negative sine x dx. Okay, and when x is negative pi, by plugging x equal to negative pi here, the u would be 0 because 1 and then cosine pi is actually negative 1, so 1 minus 1 is 0. When x is 0, that means 1 plus cosine 0, which is 1 plus 1 is 2. So this integration, whatever we're trying to find, that will be changed to 0 to 2 and then 3 sine x. As you can see that sine x dx can be replaced by negative of du. So I can just bring that negative sign outside. So it will be 3 du, and then for this one it's a square root of u du. So I can replace this problem into 3 square root of u du. This negative sign, it doesn't matter because of this absolute value, it will be eventually be positive. So now let's find out the integration of u to the power half, which is by using the power rule, it would be 3 half over 3 half, and then we have to put the limit of integration from 0 to 2. This 3 and this 3 is gone, so this 2 comes to the top, and then after using that fundamental theorem, I have to replace this u by 2 minus this u by 0, so that's 0. So eventually it is 2 to the power, it's a 1 power, it's a 3 over 2 power, so eventually it will be 5 over 2 power. So that's the area. Because there is no negative sign, we can say that that's the area of this part. And that negative sign went off. You can see that this negative sign is just gone because of this absolute value. Okay.